Ever feel like you need a secret decoder ring just to understand what's going on with AI? You're definitely not alone. So, in this explainer, we're going to crack that code together and finally make sense of the language of artificial intelligence. AI, LLM, generative AI, hallucinations. I mean, the list of new terms just seems to grow every single day, right? But what if I told you that getting a handle on these concepts is actually way easier than you think?
Just think of this as your personal map. Over the next few minutes, we're going to lay out a simple, clear guide that will help you navigate this incredible new world with confidence. Ready to jump in? Let's get started.
All right, first things first, let's start with the big one. What exactly is artificial intelligence? Think of AI as the big umbrella, the ultimate goal. It's this huge field of science all about one thing, making machines smart. Smart enough to learn, to reason, and to solve problems. It's the big idea behind everything from self-driving cars to the virtual assistants on our phones. So, if AI is the destination, how do we get there? Well, one of the main ways is through machine learning. This is a specific technique inside of AI that's all about teaching computers by example. You show them massive amounts of data and just let them figure out the patterns for themselves. And if you want to get even more advanced, you drill down into deep learning. You can think of this as a kind of supercharged machine learning. It uses these complex structures called neural networks, which are actually inspired by our own brains, to find even deeper, more subtle patterns. This is the real magic behind things like recognizing faces in photos or those incredibly powerful chatbots everyone's talking about. So what do you actually need to build one of these amazing systems? Let's take a look at the foundational ingredients. When you break it all down, it's surprisingly simple. Every AI really just needs two things: ingredients, which in this world is data, and a recipe, which we call an algorithm, to tell the computer what to do with it all. And when we say data, we're not talking about just a little pinch of this or that. We're talking about big data, these enormous, complex collections of information. It could be text, images, financial records, you name it. This is the fuel that powers modern AI. And the algorithm? Well, that's the recipe. It's just a set of step-by-step instructions that tells the AI exactly how to sift through all that data to find a pattern, make a prediction, or come to a decision. Okay, so we've got our ingredients and our recipe, but how does the machine actually learn from all this? Let's look at the different ways they can gain that knowledge. One way is called supervised learning. And honestly, the best way to think about it is like studying with flashcards. You give the AI a ton of data that's already labeled with the right answers. This picture is a cat, this email is spam. The AI just learns by example. It's perfect for tasks where you already know what the right outcome should be. But what if you don't have an answer key? Well, that's where unsupervised learning comes in. You give the AI a giant, messy pile of unlabeled data and basically just ask it to find any interesting patterns it can. A company could use this to automatically group its customers into different segments, all without telling the AI what to look for. It's incredibly powerful stuff. So when you boil it all down, the difference is actually really simple. Supervised learning gets the answer key in advance. Unsupervised learning is sent off on a mission to discover the patterns all on its own. And then there's a third way, which is really cool. It's called reinforcement learning. The easiest way to picture this is like training a puppy. The AI learns by pure trial and error. It gets a reward, a digital treat, for a good move, and a penalty for a bad one. This is exactly how AI learns to master super complex games or control robots. Okay, so that's the theory. We know how AI is built and how it learns, but what about the what? What kind of amazing things can it actually do with all that knowledge? At its heart, AI gives machines some pretty mind-blowing new skills. It allows them to understand our language, to literally see and interpret the visual world, and maybe most incredibly, to create brand new things completely from scratch. So let's talk about understanding language. That's a field called natural language processing, or NLP for short. Think of it as the bridge between human communication and computer understanding. It's what lets your voice assistant understand a question, or your email automatically filter out junk. And that brings us to maybe the most exciting area in all of AI right now, generative AI. This is where AI stops being just an analyst and becomes more like an artist. It doesn't just understand the data it's been given, it uses those patterns to create totally new, original content. You interact with it using something called a prompt, which is really just a fancy word for an instruction. You can ask it to write an email, design a picture, or, well, you could even ask it to write a simple definition for a video just like this one. Now, with all of this incredible power, you have to ask, how do we make sure that AI stays on the right track? How do we keep it both safe and honest? Well, one of the biggest challenges is this weird thing called a hallucination. This is when an AI model just makes something up. It generates information that's totally wrong, but it presents it as if it's a solid fact. And obviously, that can be really misleading if you're not careful. So, to prevent problems like that, developers build what they call guardrails. And they're exactly what they sound like. They're safety systems and rules designed to keep the AI on a safe path, making sure it operates within ethical and technical boundaries to avoid causing any harm. And that brings us full circle, right back to where we started. The whole field of AI was founded on this ambitious goal of simulating human intelligence. But as these systems get more and more powerful, we're left with a pretty profound question. What happens when the simulation doesn't just mimic us, but actually surpasses us? The answer to that is going to shape our future in ways we're only just starting to imagine.